Welcome to The Explainer, where we break down complex topics into something you can really sink your teeth into. So, you probably write Python classes all the time, but how well do you really know them? Let's dive in and uncover some of the more advanced, secret level concepts that can seriously elevate your code. All right, first up, let's talk about something that sounds a bit like a family tree drama. What happens when a class has more than one parent? This is called multiple inheritance. So, what is multiple inheritance? Well, it's basically a way for a class to inherit features, attributes and methods, from more than just one parent class. Think of it like a kid inheriting traits from both their mother and their father. Okay, let's look at some code, because this is where it gets really interesting. The child class here gets eye color from the mother and height from the father. No problem there. But wait, both parents have a speaking method. So which one does the child get? Well, Python has a rule for this, and it's all about the order. Since we listed mother first when we defined the child class, the child gets the mother's version. This pecking order is actually called the method resolution order, and it's super important to remember. All right, let's switch gears and tackle something that trips up developers all the time, the whole overloading versus overriding thing. Right? Two methods, one name. It sounds simple, but what's really going on? This is a classic interview question for a reason, and getting it right is a huge sign that you understand object-oriented programming on a deeper level. They seem similar, but they operate in totally different worlds. And this table just lays it all out perfectly. With overloading, you're in the same class. You have one method name, but with different parameters. With overriding, it's all about inheritance. You've got a parent and a child class, and they both have a method with the exact same name and parameters. Overloading makes one method do different things based on the input. Overriding lets a child's class say, hey, I'm going to do that thing my parent does, but I'm going to do it my way. And here's the absolute bottom line, the thing to burn into your brain. Overloading has nothing to do with inheritance. Zero. Overriding, on the other hand, completely depends on it. If there's no parent-child relationship between classes, you're just not dealing with overriding. Simple as that. Okay. So let's zoom in on method overloading. Now, here's a little Python-specific quirk. In some other programming languages, you can just define the same method multiple times with different parameters. Python doesn't really work like that out of the box. To achieve the same effect, we need a special tool called a decorator. And here's what that looks like in practice. We use this @overload decorator from the typing module. See how we declare a version of add for integers and another for strings? These are, well, they're like signposts for our tools and for other developers. They don't actually do anything. The real work all happens in that final add function at the bottom, which is written to handle all the different types we declared. Okay, so now that we've got overriding down, we can talk about the real payoff. This is where the magic happens: polymorphism. The word itself sounds complicated. It's Greek for many forms. But the idea is actually super powerful and elegant. It just means we can treat objects of different classes as if they all belong to a common parent class. And the cool part is, Python figures out which specific method to run at the very last second when the code is actually executing. So let's see a classic example. We've got a base animal class, right? It has a pretty generic eat method. Then we have a bird class, which is a type of animal. But the bird provides its own, more specific eat method. It overrides the parent's method. Okay, now here's the fun part, the real test. Look at this line of code. We're creating a bird object, but we're storing it in a variable that we've told Python is an animal. So, when we call the eat method on our myPet variable, which version gets called? The generic one from animal or the specific one from bird? Polymorphism. That's the answer. Python is smart. It doesn't care what type we said the variable was. At runtime, when the code is actually running, it looks at the object itself. It sees, hey, this thing is actually a bird, and so it calls the bird's overwritten method. That's the whole point, making decisions at runtime. It's what makes the code so incredibly flexible. All right, so far, every method we've looked at has been tied to an object, an instance of a class. But what if a function is related to a class, but doesn't really need a specific object to work? That's where static methods come in. So a static method is basically a function that lives inside a class, but it's not tied to any one object. You can call it directly on the class itself. Think of it like a utility or a helper function that's logically grouped with the class, but it doesn't need access to an object's personal data. That's why you'll notice it doesn't have that self parameter. And you can see how clean this is. We use the @static method decorator right above the add method. And then look, we just call mathoperations.add. We never had to create an instance like m equals mathoperations. It's just a really neat way to organize functions that belong to the class's namespace. Okay, for our final section, we're going to pull back the curtain and reveal a fundamental truth about Python that ties all of this together. It's the universal blueprint for everything. Have you ever stopped to think about this? You can make a totally empty class, create an object from it, and it just works. It already has methods like double inits or double star built in. Where do those come from? How is that even possible? Well, here's the secret. Every single class you ever write in Python, whether you type it out or not, secretly inherits from one single universal base class. It's called object. So when you write class human, what Python really sees is class human object. And this is where all that default magic comes from. That object class is packed with all of these fundamental dunder or double underscore methods. Things like underscore init, underscore string, underscore EQ for checking equality. They all live in this universal parent. So when you decide to write your own underscore string method, you're actually just overriding a method that you inherited from object. So once you understand this, that everything is built on this universal blueprint, so many other parts of Python just click into place. It's not a random collection of features. It's a really consistent and elegant design. Now that you know the secret, what are you going to build with this deeper understanding?